Hi, friends. Let's continue our discussions on visualizations. Now, let's get into the plots, the types of plots, why they are required, and so on. Yes, uh, standard saying a picture is worth thousand words. Instead of talking thousands of words, we can show one picture, and that conveys more meaning than what we could convey using thousands of words. So that's a basic concept used here in plotting and visualizing the data. The data, basically, what we have is an ocean of numbers, and as you look around, you will be surrounded only with numbers, 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 infinitely large number of numbers, and with these numbers we don't make out anything unless we try to find some details insights from this. So the plots play a crucial role in data visualization. They help in conveying insights very clearly. These plots serve various purposes and are chosen based on the data and the insights we want to convey. So there are many types of plots. So depending on the data we are working with and depending on what information or what insight we want to convey, appropriate plot will be selected. Let's see various types of plots available. So this is a list of few of the plots available which are commonly used in data science. So what are these plots are, why they are required, when they will be used, and all details we see one by one. So first let's start with bar graph. So when we have a data, the data may have multiple rows and multiple columns. So if we can represent these rows and columns with is a bar graph. Say we have three, four columns. So each column is represented by a different color: blue, orange, violet, and green, and they are repeated. So that means they are showing the data. So it is for first quarter is one first part, second quarter is another part, third quarter is another part, quarter is another part, and so on. Now the advantage of this type of graph is you can visualize one among the four types of data, that is Kent, Lincoln, Mersey, and York, which one is leading, which one is trailing, and all that. So in the first quarter, if you look at that, Lincoln is leading and York is trailing. Minimum is York, maximum is Lincoln. Same way, other things we can talk about at different quarters. Other way, if you look at it, you can compare the same, say, the Kent. If you look at it, then you just concentrate on the blue bars. So in the first quarter, second quarter, they were almost same. Third quarter, it raised. Fourth quarter, further increased. So it's trying to say that the Kent revenue is rising monotonously, whereas the green one, that is for York, it's started little high, then went on reducing, and then suddenly raised in the fourth quarter. And talking about Mercy, it looks like almost it is constant, no change. So that way we can look at quarter wise and compare between the different companies or places, whatever is meant here, or for the same data, different quarters we can compare. So these all are possible when we are working with bar graphs. The same thing can be presented as a table, but at the table we won't be able to make out this clearly what it is trying to tell. The other way of doing is a line graph. So here it is trying to show the average monthly rainfall in two cities. So it's showing from January to December, various plots or various points are plotted, and they are connected through the lines. So that's called line graph. So we can see that the orange one is a city one. It starts at a high level at January and monotonously reduces till July, and from July again it starts increasing. Almost same thing is with city 2, but in February of city 2 there is a little disturbance. So the shape of them, you can clearly tell how they are changing. So that makes the things very easy to compare what is happening between various data. So that's a line graph. Pie chart is basically used for showing share of each value. So here the total circle is total share, that is the total one. So here it is talking about the population of European Union in 2021. It's shown in terms of percentile. So the different colors are showing different countries population. So it's the red one says 18.6%. That means red, if you look at the right side red, it is talking about Germany. So Germany is 18.6%, and then France is 15.2%, Italy is 13.2%. So it if you put that in terms of numbers, you may not be able to immediately make out, but if you put that in the form of pie chart, we can easily make out and infer something like the gray one, that is rest of European Union, is making up of almost a quarter of that. So it is very clearly visible in the pie chart that quarter of that is gray colored, and the three things like red, blue, and yellow make almost half. That is Germany, France, and Italy together is almost half the European Union population, and so on. So these are the different ways we can make out through the pie chart. So this pie chart is basically used for showing the proportion of each element in the system. Then comes the histogram. Histogram talks about the number of events for the value. So histogram is basically used to see how the data is distributed. So the data, minimum maximum values of the data is taken, and this interval is divided into sub intervals, and the number of values falling in each sub interval, that means frequency of data falling in each of these sub intervals is found, and it is plotted like a bar graph, and that will show that which data has how much of contribution in our list. So the next one we talk about is area chart. Here it is same as a line graph, but only difference is the line graph, the area below that line is colored with a appropriate color. So here we can see that four different data are being plotted, 2001, 2, 3 and 4 respectively, with different colors, and the area under that is represented, and through this we can make out visually that the more area, the bigger the value, the small area, the smaller the value. So overall, from it tries to give the total. In this case, we are talking about January to December. That means 1 year. So if you just look at the overall area of the color, that will tell us annual values for that particular data. Same way we can put in terms of dots. So it is same like a histogram, but only difference is histogram we use bar charts, here we put dots. So the advantage of working with dots is we can count it and just understand how the distribution is varying from one value to other value and so on. The next one is a bubble chart. So bubble chart usually is working with multi dimensions. So here the x-axis is one dimension, y-axis is another dimension. So that talks about position of any circle or a bubble, tells about the two values of x-axis and y-axis, a pair, and then the size of that talks about another quantity. The bigger the quantity, the bigger will be the radius of the circle, and color can be used for one more. So here the three parameters: one, the x-axis parameter, another y-axis parameter are continuous, and the radius of the circles is also continuous, whereas the fourth one, which is used for coloring, is categorical. So here we are trying to represent four parameter data, three parameters of continuous domain, one parameter of discrete domain together, and they are being shown at different colors for category, and size of the circle for one parameter, position for two more parameters. So that way, in one plot, we can represent four parameters simultaneously. So in a 2D, we are representing a 4D data where three dimensions are of continuous domain and one dimension is of discrete domain. Then comes the radar chart. So here it's not limited to any number of parameters. In this case, it is working with 1, 2, 3, 4, 5, 6, 7. So it is talking with 7 parameters. So each parameter is one corner of a polygon. So because there are 7 parameters, so we have used an heptagon, and the size of the heptagon talks about the value of that particular parameter. So if you look at this in detail, then there are two curve line plots there, one in red and one in yellow. So yellow is trying to tell that creativity is more than the red's creativity, and for yellow, the skill is less than red's skill. So you can just compare the two data parameter wise and plot it. So this is a very good type of chart. When the number of parameters are more, number of data are less, in such cases we can. So in this case there are 7 parameters, there are 7 columns in your data set, whereas there are only 2 rows. So for every row one color is used, for every column one corner is used. So if there are 7 parameters, then we use a heptagon. If there are 8 parameters, we use a octagon, and so on. So depending on number of rows, so different colors are used, and appropriate values for each of these parameters are selected as the points, and they are joined with the lines, and that makes a radar chart. So this is very much convenient to use when the number of columns are very much more than the number of rows. Other way you can talk about is pictogram graphs. So this represents the this emojis like thing can be used. So here whatever we trying to represent is mode of transportation, various types of transportation used by the students to reach the school. So in the bus, so there are some number of students coming to the school. If in car, some students come by walk, some come by bicycle, some come. So how many to come? So we represent one facial picture to represent 4 children. Then count these in each of these rows and say multiply with 4. So that will tell. So that's a simple way of representing our data. Then we can talk about spline data, whereas instead of lines, we can make it a smooth curve. So this smooth curve can be represented with one polygonal expression, and that polygonal expression can be used for interpolating or extrapolating the values. The other important plot is a box plot. Here, each color represents different data sets. So here we are talking about 2 data sets. Data set 1 represented in blue, data set 2 represented in red. And when you are talking about box plot, so we talk about 5 parameters, that is minimum, maximum, median, the first quartile and third quartile. So 5 parameters are shown. So a box is drawn between first quartile and third quartile. So we find, so with that what happens is the we can understand how the data is spread. So if you look at, so we have done various number of experiments. It is shown on the x-axis, experiment 19, experiment 18, experiment 20, experiment 22, and experiment 24. So in all the cases, so two charts are drawn. So one with red, one with blue, another red, another blue. So totally 4 things are drawn for every experiment, like looks like that, and each one may be talking about various parameters. So here in the first, the leftmost set, if you look at it, it says that the blue one is having values lesser than the red one, whereas the second set talks about blue one is having higher than the uh, red one, and so on. And the dots shown there represent the outliers. So it gives lot of information like that. So when we are working in detail about all these things, we see what these quartiles are, what minimum is, what maximum is, how they are related with the median, and all that. So that's box plot. So it is trying to give the overall distribution of each variable. So in one small plot, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So totally 16 distributions are represented in one plot. So each 16 distributions are of the 4 experiments. So 4 experiments, 4 measurements, all of them are put together in one place. So much of compactness is there in this box plot. And then next one is talking about the scatter plot. It is trying to say how the one parameter is related with another parameter. So if you look at the first one, so that shown with the blue dots, as the x value is increasing, it's trying to say that y value is also increasing. So we can say that there is positive correlation between x and y. But if you look at the green points, then as the x value is increasing, y value is decreasing. So we can say that there is negative correlation between x and y. And in the third one, I don't find any relation. So if x is increasing, I can't say what is happening with y, because for every value of x, every value of y at different places are possible. Therefore, I cannot say that they are somewhere related with each other. So we can say that there is no correlation. So if we can plot the scatter plot, we can understand whether the two things are correlated or not. So this is what we were discussing in earlier. If we are talking about x and y belonging to one, x belongs to input set and y belongs to output set, and if we find some correlation, that means that output has an influence of that input, so we need to keep that input for our future work. But if x and y happen to be input side, both of them happen to be of the input side, then we understand that one column depends on the other column. So we have redundant data, so we can reduce either x or y column from the data set, so that the total size of the data set can be reduced and the computation and the whole process can be simplified. And that's the advantage of working with the scatter plot. So the next thing is about summary statistics. So that's what we were talking in the earlier. So what all summary statistics is? So it talks about what is minimum in the given data set, what is the first quartile, what is median, what is third quartile, what is maximum. So here to identify this, we just arrange the data in ascending order and then pick up the middle one, and that becomes median. And then we have minimum, we have maximum. So this between minimum and maximum, if we divide that into 4 parts, then the central part will be the median, the first part will be first quartile, then the third part will be third quartile, and so on. Then we can calculate the mean, that is the first movement. So that's in normal case, it is average of all the data if it is a continuous domain. Then mode is the one which is usually used with a discrete domain data. That's a value which is repeated maximum number of times. Then we have variance, that's the second movement, which is going to tell us how much it is spread across the mean. The skewness is the third movement, kurtosis is the fourth movement, and so on. So that's different parts of the box plot. So what we do is we first identify the median and then quarter 1 and quarter 3. So the difference between first quarter and third quarter is called interquartile range, IQR. And then from first quarter you come down by 1.5 times IQR, that becomes minimum, and same way move up 1.5 times IQR from quarter 3, and that becomes maximum. Anything below minimum is outlier, anything outside above maximum is an outlier. So that way it is defined. So everything depends on the IQR, that is interquartile range, because most of the data are within this interquartile range. So these are the expressions used for finding various quantities like mean, variance, skewness, and kurtosis. So to understand the difference between mean, median, and mode, if it is a symmetric Gaussian, then mean, median, mode all are equal. And if it is negatively skewed, that is the orange curve, if you look at it, then mean will be minimum value, mode will be maximum value, and median will be in somewhere in between. That means if you compute the mean, median, and mode of this data set which is negatively skewed, then mean, median, and mode are distributed in this way. So mean is smaller than median, median is smaller than mode, and so on. And other way, if it is positively skewed, mode will be smaller than median, median will be smaller than mean. So if we can compute mean, median, and mode, and if all of them are equal, then we can say that it is symmetric. If they are not same, then it is skewed. Then depending on the relation between mean, median, and mode, we can identify whether it is negatively skewed or positively skewed, because this skewed data is going to create inaccuracy in our future measurements, and also we need to do some pre-processing and try to make it as much symmetric as possible before continuing with our further activities. So for that we need to understand what type of skew it is and what is kurtosis and all that. So these details will be studied in detail in our next session. So keep watching. Thank you.